Let's talk about the system design of URL shortener. URL shortener is a service that takes original URL and return the short URL. The core functional requirement will be URL shortening. The system must accept the original URL and return short URL back. Redirection to the original URL. User will enter the short URL and user must be redirected to the original URL back. Analytics. User must see the analytics insights of that URL. If I talk about the non-functional requirement, high availability, which means the system must be available all the time. It should accept URL and do redirection. Low latency. Low latency refers to the redirection must happen in very minimal time. High durability. High durability represent the system must keep the shorter URL for long period of time. Let's explore the traffic assumption. We assume that we have 100 million active users and we get 100 million daily new URLs. The read writer should be upon 100 reads there is one write. So as per read write ratio, we get 100 million writes each day, which is 1160 writes per second, and 10 billion reads per day, which is 1,50,000 reads per second. As per the assumption, we understand that the system is read heavy, and whenever we see the system is read heavy, we think of caching, and as per this we need to use Redis or any caching system extensively. Let's dive into API endpoints. The first API would be for post to create short URL which takes the long URL and return the short URL back. Another API request would be get, which takes the alias which is the short URL or the ID and returns the long URL back. Now let's satisfy the functional requirement one by one. The first is URL shortening. The system must accept the original URL and return the short URL back, which involves a client shortening service. It would be HTTP server that converts and stores the URL into the database. Now let's focus on the architecture. So it's a version 1 where there is a client which sends the long URL and the HTTP server will which generate a random ID for that short URL and map into the database. Now let's extend this furthermore. Here is the proper design for URL shortening. The client will send the original URL. It will go through the API gateway. API gateway will be responsible for rate limiting and DDoS protection. Then API gateway forward request to the load balancer. Load balancer will distribute requests among the servers. It's a horizontal scaled HTTP server which accepts the long URL or original URL and again map with the ID and store into the database. As we get the 100 million new URLs, so we need a scalable database system, and so that's why we will use sharding and partitioning technique. We will shard the database as per the URL, the alias that the HTTP server generated, and as per that we store that into the database. Now let's see how URL redirection will work. So as we want the low latency, so we need an approach that map the long URL or map the short URL to the long URL at the user side. So that's how we can achieve the minimum latency. So there is a one way. Client will enter the short URL into the browser, then the request will go through the DNS. We'll use CDN because CDN can also use for catching HTTP request. So whenever client enters the short URL, the request will go through the DNS. DNS will resolve the nearest CDN edge location. If CDN has the catching for that URL, it will simply return from there. If it doesn't, it will again forward request to the load balancer. Then load balancer will distribute request among the servers. Then server will check into the Redis cache. If it have, then it will return from there. If it doesn't have the in cache, it will look up in the database as per the ID, and that's how the redirection will work. But here is a one issue. As we are using CDN, so achieving or for analytics it's become harder. So now let's address that issue. For analytics, we can use logs generated in CDN. So we'll get that logs and push into the Kafka. Kafka will feed that logs into the analytics service, and an analytics service do some operations and put into the in-memory database, which can be Redis, and then it will periodically push into the original database. So we can also use a database like ClickHouse or time series database.